Hi everybody, my name is James Connor, also known as Sprayer James, and today we're going to go over the inspection and calibration of a golf course sprayer. If at any point in this video you feel overwhelmed, just give us a call and we can come and take care of this for you. Some of the tools we're going to be using today for our calibration are a graduated measuring cup, a spot-on nozzle calibrator, a scrub brush, and a stopwatch. The two main things we're going to be doing today is first an inspection of the sprayer, and then we're going to be making sure that the calibration is correct as well. The first thing we're going to be checking today is the integrity of the tank itself. We're do this by we're going to open the lid. We're going to remove the basket, or in this case, it's got a melting pot. And we're going to have a quick look inside, making sure that our agitators are there and that the tank is free from defects. Here on the Toro 5800, we've got our agitators along the one side of the tank. We're just going to make sure that they're all present and not missing. All right. The tank looks good, so we're going to put our melting pot back in, and we're going to close the lid. So after we check the inside of the tank, we're going to take a quick visual look at the outside of the tank for any obvious damage or defects. So I'm just going to check the top of the tank, ensure that our tank straps are nice and tight. Take a look, make sure we don't have any cracks or damage. And we'll check the other side as well. Perfect. Looking good. Okay, so I guess we'll come around to this side. Now that we've had a look at the tank, the next thing we're going to want to check is the frame that the tank sits on. So we're going to do a quick visual inspection of the frame, keeping an eye out for any cracks or broken welds. Keep in mind, everybody, that a liter of water weighs a kilogram. So when this tank is full, it's an extra 1,100 kilograms moving around with you. So that's why we want to make sure the frame is not damaged. Looks good to me. So after we check the tank, we want to make sure that the lid is in good working order as well, so that it seals well and we don't have chemicals spraying everywhere. So we're going to inspect the gasket. The gasket looks good. We can hear the rattle of the ball that prevents water from coming out, and it seals well. Opens and closes smoothly. Next, we're going to be taking a look at the filters to see if they need any cleaning and make sure they're in good condition. Get my handy brush ready. We're going to remove the pin. These are always a bit of a pain. And we're going to be looking at the state of the O-ring. As you can see, this one's been a little bit damaged. We'll be replacing that. Here we have a little bit of damage on the O-ring. We'll be replacing this O-ring. The reason why we want to make sure that there's no damage is because if we introduce air on the suction side, we'll reduce the ability of our pump to pump water. Air is compressible and water is not. So if we allow air into the pump, then it will compress and it won't actually move anything. Next, we're going to be taking a look at the filter itself. Here we have the suction filter. It's a nice coarse filter designed to catch any debris that comes through the tank. As you can see, we've picked up a little bit of, looks like a bit of plastic, and possibly some undissolved fertilizer. And we'll just be cleaning that out with our trusty brush. We want to make sure we clean both the inside and the outside of the filter. Good. The next thing we're going to look at are the valve bank itself to make sure that we don't have any loose valves or any missing parts. Here we have the valve bank on the back of the sprayer. We're just going to make sure that everything is secure and that nothing is missing. Everything looks good. So what we're going to be looking at is the suction line itself. That would be this big line that runs from the top of the tank. On this case, it runs from the top of the tank, but on most other sprayers, it's located on the bottom of the tank, and it's the hose that goes from the tank to the pump. We want to make sure that this hose isn't worn and there are no punctures in it that are going to either leak product or introduce air into our mix. And this one looks good. The next line we're going to be taking a look at is the discharge line. This would be the line that goes from the pump up to our valve bank. This is a nice short one here, and we're just going to be checking it for any damage. An important thing to note is anywhere where the hoses are going to rub up against each other, we want to take a good look at so that we don't have a situation where a hose is rubbed through his neighbor. And they look good. Next, we're going to be doing a quick visual inspection of the pump itself. On this model, it is a 3 diaphragm positive displacement pump. So we're going to make sure that the oil level is in between the max and minimum lines. The oil is not milky, and we don't have any leaks coming from the pump. Okay. One of the parts that we have to check on a positive displacement pump would be the pulsation dampener, located right here. What we're going to do is we're going to make sure that it is the correct pressure inside the diaphragm. The pressure in the diaphragm should be roughly half of whatever your normal spray pressure is. So I'm going to take out my trusty little reader here. And we've got nothing. Perfect. So, you could put air into this diaphragm with a normal shop hose, but because it's such a small vessel, I just like using a bike pump. Okay, that was fine. It's holding. Perfect. Now that we've put some air into it, we'll check it again. Perfect. Okay, it's about 20 PSI now. I'm going to replace our cap. It should be noted that if you are testing the pressure there and any water comes out of this little nipple, it means the diaphragm inside is torn and should be replaced. All right, on to the next step. The next part of our inspection is going to be ensuring that the pressure gauges are all working correctly. So we want to ensure that our pressure gauge isn't bent or damaged and that the needle is sitting right at 0. If it's sitting anywhere else, it means that the pressure gauge is not going to give you accurate readings and it should be replaced. So we've checked the suction filter. The next filter we're going to check is the discharge filter. So the filter that is on the discharge side of the pump. And that is around on the back here. Here we have our discharge filter located in the valve bank. As we can see, it's got the red knob on the bottom, which means it's a self-flushing filter. I'll show you what that means in a sec here. We're going to unscrew the collar and carefully remove the filter. Here is our filter cartridge. You can see there's a small amount of buildup, which is normal. We'll be cleaning that off in just a moment. The next part we're going to look at is the operation of the self-flushing filter itself. To do that, we are going to disassemble the filter and make sure that the self-flushing portion of it is clean and operating correctly. I'm going to need my pliers. Okay, so we're going to grab our center post here and we're going to untwist it. Just like that. Okay, out comes our self-flushing portion. And now we can remove the rest of the filter housing to give it a quick rinse and scrub and make sure it's nice and clean. The last part of this we're going to be taking a look at is the adjuster knob for the self-flushing filter itself. We want to make sure that there is no debris inside here and that any water that we put in the housing gets returned back to the tank. Looks nice and clean. And you can see as we lower it, we've got water flowing through, so we know the hose is not obstructed, which is good. That's what we want to see. Okay, so here we have the filter cartridge. We're going to be giving it a quick clean. We can do this with just water, but I like to use a bit of Kodiak degreaser because it helps break down some of the sludgier stuff that can be caught in here. So going to take our little scrub brush. We're going to scrub each one of these little elements individually, making sure we free up any debris that gets caught on there. And we're also going to do a quick scrub of the inside as well. Okay, nice and clean, no more debris. It should be noted that this one is not twisted or crushed at all. It is in good condition. All right, now we're going to reassemble the self-flushing filter. So to start, we will take our filter housing, have a quick look. It is free from debris. Take a look at our O-ring, which looks good. Okay, so we're going to take our housing, make sure you've got the collar on it. And we are going to line the 2 feet on our filter with the 2 notches on our adjuster. Just like that. Yeah, we'll reassemble the housing in the reverse order that we put it together. Everything is gasketed, so hand tight is all we really need. As long as it doesn't leak, we are in business. Next, we're going to reinstall our filter element. You should note that there is a large opening and a smaller opening. We want to put the large opening down. It is seated well, and now we will reassemble the filter back together. It should be noted that this should only be hand tight. If you have to take a wrench to get it off, then you've over tightened it. The gasket that's in there will do all the sealing work, so all we need is hand tight. All right, the next part of our inspection is to inspect the flow meter. This one in this particular case is our Orion electromagnetic flow meter. I highly recommend this one. It has no moving parts, it doesn't need service, and they don't wear out. This one uses Faraday's law to tell how much water is passing through. Faraday's law states that a conductor moving through a magnetic field generates a current. In this case, our conductor is the water passing through. The magnetic field is generated by the flow meter, and the current it generates is translated into how much flow is going through our flow meter. All right, the next part we're going to be taking a look at is the operation of the regulating valve and the boom valves. On this particular unit, because it is an individual nozzle control sprayer, we don't have any section boom valves to test, but we'll be testing the individual nozzle control in just a minute. The way we test our main control valve, we put the sprayer into a manual mode and we just listen for its operation. You should be able to hear it with most regulation valves on the market. Now we're going to move on to the visual inspection of the boom itself. We're going to be taking a look at all the hoses, all the cabling. If your sprayer is equipped with individual nozzle control like this one is, we want to make sure that our cables are in good shape and they aren't in a position where they're going to get snagged by any foliage. Okay. The next thing we're going to look at are the breakaways. These are designed to sort of, if you come into contact with a tree or a bush, to move out of the way so that the boom isn't damaged. And this should have a full range of motion. The next thing we're going to take a look at would be the hoses themselves that connect all the nozzle bodies together. We want to make sure that they're free from cuts or nicks. Any points where they would rub are not worn. Before we move on to the mechanical testing of things, we want to make sure that if we have any nozzle screens, that those are nice and clean and free of debris as well. So we'll undo it, wiggle that off, take our nozzle screen and our nozzle and just drop it into our bucket. Perfect. I'm going to take our nozzle screen and we're just going to give it a little brush with our handy toothbrush. And then maybe we'll show a dirty one next to a clean one. Okay. We can see one that's got a bit of debris on it and one that we've cleaned up. So to reinstall these, we're going to put our filter up into our nozzle body and then click our cap on. For this next part of the calibration, we're going to start up the sprayer, get the pump running, and start taking a look and making sure the water is flowing around inside the tank. The next part of our inspection is to inspect the nozzles themselves for wear or funny spray pattern. The tools we're going to be using are our spot-on calibrator, our pressure gauge, our jug, and our stopwatch. The first thing we're going to do is install our pressure gauge on a nozzle body. Our nozzle just goes on the bottom, and our pressure gauge clips on just like that. Each one of these nozzles is rated at 40 psi, so we want to make sure that our pressure is at exactly 40 psi so that we get a good reading of how much water is flowing through the nozzle. All right, we've got our pump running. I'm going to start spraying out of the boom. I'm going to adjust our pressure to 40 psi, and then I'll start testing nozzles. That is right at 40. Here we are testing each nozzle for flow and consistency to ensure that when we test the flow meter, it doesn't matter which nozzle we choose. They'll all output the same. If any nozzle is off by more than 10%, it should be replaced. This is our spot-on calibrator. It does the same job as we did with the measuring cup and timer, but it's all in one nice, neat package, and it saves us a little bit of time. The way it works is we power it on. The water will fill the chamber. When the water hits the bottom post, it starts a timer. When the water hits the top post, it stops the timer. And it knows the volume of this cylinder, so it can give us an output in gallons per minute. There. And the gray nozzle should be 0.6 gallons per minute, and we're at 0.59. Which is well within the margin of error. Okay, for the purposes of testing the flow meter, we are going to simulate a speed. So on the Ninja, we are going to hit the menu button, and then we're going to hit the little wrench menu. We are going to go to speed source and change it from GPS down to simulation. And then we're going to go back to our spraying menu. Okay. Now the system thinks we are doing 3.7 miles per hour. And we can adjust this up and down. We're going to be testing at 4 miles an hour. All right, now we just have to fire up the sprayer and get spraying. Here we've simulated the speed that the sprayer is going at, so we can do our catch test sitting still. We're going to be catching for 30 seconds and verifying what the computer indicates is coming out is what we're actually catching in our jug. All right, so now we are going to verify that the amount that we collected matches up with what the sprayer thinks its output. We do that by first we take our desired rate, which in this case is 75 gallons per acre. We multiply that by the speed we were simulating, which is 4 miles an hour. And then we multiply that by the nozzle spacing. In this case, it's 20 inches. That gives us 6,000. We take that number and we divide it by a mathematical constant. For gallons per acre, it is 5940. So we take 6,000 divided by 5940, which gives us 1.010101. That would be in gallons per minute. We are going to bring it down to ounces by multiplying it by 128. And then, because we caught for 30 seconds, we're going to divide it by 2. That gives us 64.6 ounces. And we compare that to what we caught. Which is pretty bang on, if you ask me. Perfect. This flow meter is accurate. And we only have one test left to do, and that would be the speed test. To test the speed, we compare the distance we've driven with how far the computer shows we've gone, and adjust the computer until it matches the distance we've traveled. All right, so I'm comparing what my wheel shows to what the computer thinks how far we've traveled, and they both match up, which means the speed setting is good to go. So now that we've completed the calibration, we know that our sprayer is accurate. We've inspected the entire machine, which will give you peace of mind when you're spraying down the road. All right, if you have any questions about any of the things we've covered today, you can feel free to reach out to us and like and subscribe the video for more content in the future. Happy spraying.